Okay, everything seems to be clear, and we're all excited about Trilinos. We're all excited to get started with the tutorial. So let's move on to the first tutorial, and I'll take the opportunity to give you a preview of the rest of the day. So we've structured the tutorial into 3 parts. There's going to be a part about how to install Trilinos and how to use Trilinos, to include Trilinos in your application code. And that's what we're going to do right now. And so I'll show you some more slides with some background on the Trilinos build system and how to interact with it. And then we'll all going to switch to an hands-on exercise where you can configure and compile Trilinos for yourself. And after that, there's going to be a second part that Alexander will present, where we're going to look into how to work with the first steps with tpetra, and where you can for yourself assemble a linear system in tpetra and see how that's done. And then there's also going to be, of course, a hands-on session where you can try that for yourself. And then there's going to be a third part where we then use or provide various types of linear systems, and you can use iterative solvers from Delos and preconditioners from FPEG2 to actually solve that linear system. And you can, in the hands-on session, like instantiate those solvers and configure them for yourselves and see how they work. We're not going to go into so we're not going to cover all solver options, of course, but we give you some hints and a first exposure to the solver settings in Trilinos. So this is what's going to happen within the next couple of hours. So there's always going to be some theory or it's not that much theory, it's more some slides, and most of the time is going to be hands-on coding so that you can try things for yourself. And if there are questions, we will try to answer them and to help you. And of course, we're gonna take a couple of breaks in between. Okay, so when you want to use Trilinos for things to install it, and there are different installation mechanisms. Some operating systems provide Trilinos through their package managers. However, then you do not have control over the packages that you want to enable or disable. And so I personally, I say one thing at front. Much of the things that I'll share with you about installing Trilinos comes from my personal experience. So some of the recommendations that I give, it's just the way how I work with Trilinos for a couple of years now. I feel that it worked out for me quite well. Doing it in the style that I present you today. Of course, other people might have different opinions, different experiences. And for sure, in the end, as usual, there are multiple approaches that lead to your goal, to a goal, and that help you to achieve what you want. So in theory, some operating systems provided through the package manager, that's not what I would recommend. You can, as an alternative, and that's becoming more and more popular, use SPAC. SPAC is, for those of you, some of you might know it. For those who don't know it, SPAC is kind of similar to a package manager, but it creates or installs software. It builds the software from the source code on your machine, so you don't just download and install pre-compiled binaries. It's fairly easy to get started with SPAC. and it automatically takes care of any dependencies. So if you want to install Trilinos and you need some third-party libraries, Spec automatically recognizes that and also installs these third-party libraries. And it allows you to maintain multiple versions of Trilinos on the same machine if you want to have different release versions, for example, for different application codes or for whatever reason. However, and this is also related to the fact that there are so many packages in Trilinos, it's still quite tedious to prescribe these configurations within the spec syntax. At least that's my experience. And then as soon as you start developing Trilinos, you probably want to go for the last option here, and that's also the one that we're going to cover today, which is a manual installation from source code, which gives you really full control over the configuration of Trilinos. You compile and build and install from the source files. And as I said, it's especially recommended if you plan to modify the Trilinos source code or to actually develop and contribute to the Trilinos repository. I quickly mentioned that Trilinos has some dependencies. Some of them are, let's say, rather mandatory. Some are very optional. And of course, I mean, since Trilinos targets parallel computing, most of you will want to use MPI. Sorry. Then as most codes, at some point, we just rely on BLAST and LAPACK, or maybe, just for linear algebra computations. And there are other popular packages out there that Trilinos relies on, especially Metis and ParMetis or HDF5. You can also, of course, link in externally developed technology. For example, here's listed MUMS as a sparse direct solver. But, well, you don't have to. This is a purely optional thing. And which of these third-party libraries you want to include is something that you control within your Trilinos configuration file. And that's something that we're going to look at today in detail. If you want to install Trilinos from source, then you need to interact with the build system. And if you look at Trilinos, it's a large software project with many internal and external dependencies. So you really need to manage those dependencies properly. The Trilinos package architecture, so this division into these 57 packages, allows for a great deal of software modularity, but it also requires you to handle that properly. You need to enable or disable certain packages while keeping in mind their dependencies. And of course, that's something that you want to automate so that some tool can help you to not lose track of dependencies and things like that. And this is why Trilinos uses TriBITS, the Tribal Build Integration and Test System, for configuration, build, installation, and test management. So this is kind of the core of building Trilinos. You will interact with the TriBITS build system. What we're going to do now is we have a brief look into TriBITS in general and see how to, and then also see how to configure, build, and install Trilinos with a small set of packages, and then then you have the chance to do that by yourself. So first of all, what's TriBITS? So TriBITS is specifically designed for large software projects to satisfy the requirements that you maybe need to deal with multiple software repositories and distributed development teams, that you have multiple compiled programming languages, C, C++, Fortran, for example, and mixed language programs, that you have multiple development and deployment platforms, various types of Unix machines or macOS or different supercomputers. And TriBITS really aims at enforcing a stringent software quality requirements throughout the entire project, especially by providing a series of testing capabilities and test mechanisms to help you to test your code on a day-to-day basis. TriBITS itself is a standalone build system for complex software projects. It's built on top of CMake, and it provides a custom CMake build and test environment. It looks, TriBITS is written in the CMake language, and at some parts it looks a lot like CMake, but it's different. In recent years, there's been a major refactoring of TriBITS to also account for recent changes in CMake, but I think this goes beyond today's introduction. Very quickly, the question why one should base such a software project on TriBITS. I mean, it's on CMake. CMake is an open source tool used by many people in the community. And it comes with the CMake and the C-test product part, which basically helps you to not only build but also to test your software. And I think that's all I wanted to say about CMake, since I think that this is quite common knowledge, and it's very widespread in the community. So why should you then not only use CMake but actually use TriBITS, or why does also Trilinos use TriBITS? It's because it's a framework for large and distributed multi-repository CMake projects. So really for large software systems, the most probably one of the most important features is that it reduces boilerplate CMake code by providing CMake macros within the TriBITS build system, and it enforces consistency across large distributed projects. It helps you to handle sub-project dependencies and namespacing architecture by the definition of or introducing the concept of a package, and you get automatic package dependency handling for building your code and for testing your code. There's additional functionality that has been missing in raw CMake quite some years ago. CMake has caught up and has added more functionality. So TriBITS in some parts can now kind of directly use the native CMake implementation. And TriBITS alters the CMake behavior at places where TriBITS believes that it's necessary and beneficial for the user. So now if you work with a TriBITS project, then there are some terms that you just need to be familiar with. They're listed here on the left. The overall or the pendant to a CMake project is just a TriBITS project. It's kind of covers the complete project, and it specifies the overall project settings. And there's something called a TriBITS repository, which is not that important for today's topic. What's really important for today are TriBITS packages. So a TriBITS package is a collection of related software and tests, so things that belong together, software plus tests. And a TriBITS package always comes with a list of dependencies on other packages and on third-party libraries. And these dependencies, they can be required dependencies, or they can be optional dependencies to be enabled or disabled by the user. And the TriBITS package also includes can include a set of tests and helps you with namespacing and documentation. For having this idea of packages, of course, one can come up with the idea to introduce sub-packages to partition. So in case that a package becomes too large, you can partition a package into sub-packages, which then also come with the same properties as a as a TriBITS package, just at a smaller scope. And then there are TriBITS third-party libraries, which allow you to specify the dependency on external libraries, and also these libraries, they can be either this can be required dependencies or optional dependencies. And within the TriBITS build system, this is the last point here, you have a single definition across all packages. So let's say if you include HDF5 for one of the TriBITS packages, then you have to guarantee that it's going to be this exact same HDF5 is going to be used for all the other packages. If we now look, so the most important part that we're going to talk about today is this TriBITS package, this concept of a TriBITS package, and we also briefly will touch upon the project and the third-party library part. If we now look at an example from Trilinos, then I drew up here a small dependency diagram where I say, okay, I want to write or want to set up an installation where I use iterative solvers from Velos, preconditions from IFPAC. The linear algebra should come from TPetra, and then I might also want to need some direct solvers. In Trilinos, I usually always need Tefos for some utility functions, and then I also have Cocos. And I now see here with the arrows, so the solid arrows are required dependencies between the packages as they are defined in the Trilinos build system, and the dashed arrows are optional dependencies within the Trilinos build system. We will now look at how this would look like in the CMake command, when you actually want to invoke the CMake command to enable or to create a configuration that represents all these packages. And you see here on the left, so you call CMake, you specify whatever CMake language options you want to specify. This is the, let's say, the standard CMake code. Then in terms of Trilinos, you might want to disable the fact that all packages, so you do not want to enable all packages by default, because you want to only compile and install what you need. And now if you look at the diagram here, okay, every blue box is a package that we want to enable. So we, for example, want to do Trilinos enable Amisus2, and we set the bool to on. So we really want to enable Amisus2. We want to enable Velos. We don't want to enable TPetra. Sorry, we want to enable Velos. We want to enable IFPAC2, Mulu. Mulu is not part. I want to disable Mulu. So Mulu is not part of the diagram here on the right. So we disable Mulu here by explicitly setting it to off. This is just to show you how to set something to off. And then we also want to enable Tefos and TPetra. Now we have two optional dependencies in the diagram here on the right, namely these dashed arrows. And this is, for example, to say that Velos should depend on TPetra, and we do so by specifying that Velos should enable TPetra support, or that IFPAC2 should enable Amisus2 support. The fact that there are some indentations here doesn't matter. That's my very personal style of somehow structuring the CMake command. You don't have to follow that. You also can put everything in one line and it will still work. It might just be harder to read. And then in the end, we specify some dependencies on third-party libraries. So you just saw that so this is like the basic idea of how to enable and disable packages within the TriBITS build system. And we'll now have a quick look at what we're going to do today, and then talk about some of the details that you need to complete the exercise. So in the tutorial that we're going to do now, or that we're going to do later, we do not really look into developing software using TriBITS, because this is just way beyond the scope of this tutorial. If you're interested in that, here are some resources on TriBITS itself. Today, we're really going to focus on building Trilinos using TriBITS. So in particular, we're going to look how Trilinos is structured. We heard already a lot about it with the packages, and we're going to see how to invoke CMake to enable or disable some of the packages, and then finally build and install Trilinos. I mean, how to, maybe many of you know how to invoke CMake. Let's say you just type CMake and pass it a bunch of options with -d and then whatever option you want. You've seen already in this tiny example a couple of slides ago that just for 5 or 6 Trilinos packages, you need maybe 7 or 8 options. So it might get quite tedious to put everything into one line. So I highly recommend to use a configure script to have all these options listed in one place and to not always have to type them at once. This really helps you if you want to reproduce a given configuration, a well-established configuration, or if you want to reconfigure. It helps you if you want to debug a configuration, because you might have screwed up some of the dependencies and really want to look into the details there. And of course, it also helps you to just share your configure script with colleagues and collaborators so that they can reproduce the same build that you have. So I highly recommend to always invoke the CMake command through a configure script, and this looks kind of like this. It's just some sort of bash script. You might define some environment variables for certain paths that you need during the CMake command, and then you just list the CMake command as part of the script. Some quick remarks. I highly recommend to do an out of source build. Some projects force you to do that anyway, and this basically means that your build directory should not reside inside your source directory, to keep the source directory clean from build artifacts. And then you can very often choose if you want to have the build directory and the installation directory to be the same or not. Trilinos allows you to install into the build directory. Some other projects don't. So if you now want to write your own configure script for Trilinos, and that's what we're going to do in a couple of minutes, then I found the following outline of a Trilinos configure script very helpful. So first, so we basically go through these steps here on the left. Sorry. So you first, well, select your favorite shell environment. You might then define some environment variables with the necessary paths. And I always do this at the top here so that it's just collected in one place and it's not scattered throughout the CMake command here. And then there comes the actual CMake command. And within the CMake command invocation, you can also maybe identify 4 different blocks. One, which I usually took, one is some compiler settings where you just pass regular CMake commands onto CMake to configure the compiler or to specify the installation directory and things like that. Then there are general Trilinos settings, for example, the one that we saw before, where you say, okay, yeah, let's not build all packages by default, but rather select individual packages later. Then there's the main part, starting here in line 15, where you now go into the detailed package configuration and where you for each package can select whether you want to activate it, like here for MSS2, or whether you want to deactivate it, like here from Mulo. And then finally, the last part is some third-party libraries that Trilinos might rely on. As I said earlier, the structuring and also the indentation that I use here, that's just my personal preference. So there's no technical reason that you follow this. And another remark is that there are ongoing refactorings in TriBITS. So in the future, the distinction between a package and a third-party library might vanish. TriBITS developers are currently working on that, and I expect this to happen rather soon, but I'm not aware of a specific timeline yet. Once you've written how to configure, build, and install Trilinos, is you first maybe you should create your desired directory structure. So the source code directory where you clone the Trilinos repository, and then create your build and install directories as you wish. You get the source code by cloning from GitHub. You write the configure script as I outlined on the previous slide. You run the configure script in the build directory. Then you can build just by typing make and maybe build in parallel. And then finally, you can install everything by make install. Now, if you just compile and install Trilinos, that might not be super useful yet, because then it's only Trilinos, and you want to actually include it in your application code. So let's also quickly look at that. If you want to do that, you need a CMake version larger than 3.17, and you need Trilinos to be installed. Now there are two tasks. One is to make Trilinos available to the build configuration of your application code, and then to include the Trilinos headers and instantiate Trilinos objects within your code. The goals here are very quickly to assert that all the packages that you ask for, that you want to use, that they're really installed. You may want to use the same compiler and linker settings in your application code as you have used them in the Trilinos build. And you want to make sure that you properly set up and tear down your parallel environment, for example, MPI and or Cocos. And we quickly touch upon these topics. I will go through these slides now rather quickly, because this just shows you some of the commands that you will use later when you, in the tutorial, where you have detailed instructions, and then you can like experience them firsthand. So in your application code, when you write your CMake lists files, as I said, we have a minimal required version. So you set the minimal required version to 3.17 something. Then you declare your project. You give it any name. And important is here that you do not specify the language yet. We will do this later. And this helps us to make sure that the application code uses the same compiler and linker settings as Trilinos. Then this is the core part to actually identify or to find the Trilinos installation in your system. You call the find package command. You search for the package Trilinos. You say it's a required dependency. And so in the tutorial, we want to have the components Tephos and tpetra. Now, after you've found Trilinos, you can set your compiler settings of your application code to match those of Trilinos. So you set the CMake CXX compiler to the same as the Trilinos CXX compiler, for example, and so on. And finally, you can now enable the specific languages that you want to use in your code, and then build the application and link it to Trilinos using the following statement. So this here is this is standard CMake code. So you might be familiar with that already. And then finally, now in your code, since Trilinos has been installed on your machine and you can you've found it during the configure stage, and you can now include any Trilinos header just by pound include in your source code, and then instantiate any of the available Trilinos objects. In order to run your computation in parallel, you need to set a parallel environment, and it's recommended to do this by using a tpetra scope guard. Of course, you can also manually invoke MPI init, and then you have to do MPI finalize in the end, and their Cocos equivalents for initialization and finalization as well. But if you conveniently use the tpetra scope guard, this just takes care of this for you, and it hides the implementation details away. So it's just you go into your main, you call the tpetra scope guard, and then you put everything like inside the scope, and you don't have to worry about setting up and tearing down MPI and Cocos whatsoever. And then here, that's a command that you will also see in the tutorial. It's just how you, for example, now can access the communicator that has been set up with through the tpetra scope guard. With that, I'm done with the, let's say, with the slides part, and we now move on to the first actual exercise. And I give a quick introduction here. So the idea now is really that everybody can have a first-hand experience with Trilinos. And for this, we designed a set of hands-on exercises. We've provided a repository on GitHub that allows you to build a Docker container. And I really, really hope that many, or at least enough of you have read through the email that I sent out last Thursday, and have prepared that Docker container, because building it takes some time. If you have done so, then that's great. If you missed the email, well, you didn't miss the email because you're here. So but if you didn't find time to set up the Docker container yet, we'll work in small groups now. So maybe some of the other people in your group will have hopefully set up the Docker container so that you can still participate in the exercise. The exercise is now in a way that there are in this repository, there are some code snippets where just some parts are missing, and and then you are guided through instructions in a README file where there are some tasks and explanations, what you need to do, which code you need to complete where in that file, and how to compile it and how to run it. So this should allow you to get a first exposure to the configuration process at first, and then to the process how to include Trilinos into an application code. As I said, we will work in small groups now. So in a minute, I'll create a set of breakout rooms, and I will just randomly assign 3 to 5 people to each room, so that you're in a, let's say, small group, and you can work together, have the possibility for collaboration and discussion, and also maybe solve problems together. And you should be able to share your screen. So in case that somebody doesn't have the Docker container readily available, maybe somebody can share a screen, and you can do things together. Alexander and I will try to hop through the different breakout rooms and help you if there are any questions, or if you need any assistance at some part of the tutorial. If you're inside the breakout room and have a question, please raise the virtual hand, and then I think we should see that and can come and try to help. There's no pressure to finalize the exercise, because we also provide solutions right away, so you already have them. If you you don't get it done, or well, just have a look at the solution later. There's no need to get the exercises done right now. And of course, we also try to, the following exercise for assembly and solving a linear system is independent of this one. So if you really struggle to configure Trilinos, or especially, I mean, then if you configure it successfully and then you want to compile it, it takes time. So if it doesn't compile before we move on to the next exercise, don't worry. The container comes with a pre-installed Trilinos that can be used for the other exercises. So also there's nothing to worry about. So this first hands-on session, this is the final slide now, consists of 2 parts. First, you're gonna configure Trilinos, which means that you're gonna write a configure script for Trilinos that enables these packages. And of course, you might need further packages and might fix some configuration errors in the process. And you can configure and build Trilinos with this configuration. And you can find all the details and all the material for these exercises in the Trilinos Docker repository under exercises x01 configure. When you have done that, so when you can successfully configure and build, or let's say if you can configure and start the build, then you can move on to the second part, which is where you actually want to try to use Trilinos in an application code, where you will go through the process of completing a CMake lists file to include Trilinos into your application, to initiate the parallel environment, to get some Trilinos object, in that case, the communicator, and do something with it. And you can find all that material in the exercises and the directory exercises /x01 CMake. And also here, we made sure that these 2 exercises are independent of each other. So you can start with the second one if you're still compiling with the first, or if you really have trouble with the first exercise. Okay, with that, I stop sharing